Hi students, this is Miss Taz. Sorry that I can't be there today with you. If you recall, I told you some sad news on Monday. So I am I'm out with my friend for today for the funeral. So, all right, first thing I would like you to do is take out your homework. And the substitute, I may ask at times for you to pause this, so I may need you to stay near the computer so that you can pause when I need you to. So everybody should be getting out their homework. I'm sure that you all did it and found it on Edline. My other class did, so I know that you guys did. So what I'm going to do is I'm going to go through and talk about what the homework was. Later on in class today, you're going to have an assessment where you have to go through and you have to use your knowledge from this homework and the lesson today for that assessment. So keep that in mind. All right, very first one is you had to graph the points and then find the slope that passes through each pair of points. So what you should have first done is you should have plotted the 2 points, okay? So if you plot the 2 points there, that's where 2, 1 is and that's where 4, 6 is. So then you would find your slope. I don't have my cool little pen thing today, and so I am trying to use the mouse to draw, and so it's not going to be very pretty. So from here to here, we're going to rise and run. So that's how you're going to figure out your slope. You're going to rise and run. So Tyler B., how much am I rising and how much am I running?
Yay! It's a goldfish.
That's my son Cole, who's over there fussing about goldfish while we're recording this. Okay, I had to pause it. Go ahead, Cole.
Sorry.
Yeah, he's apologizing. He was mad because his brother ate all the goldfish, so that was a little bit of a fight right there. All right, so here we go. Tyler B. should have told us what the solution was, which should have been up 5 and over 2. So the slope here you should have gotten is 5 halves. Here we go. Problem number 2. You're going to graph those. And here's where your points would be. -4, 6 is up here. 5, -2 is down here. So again, what we're going to do is we're going to do well, you can't rise here, so we're going to fall. We're going to fall, and then we're going to run. Ooh, see, I told you that's not very good. All right, so Gabrielle. Gabby, tell me, how much did we go down and over? I hope you said 9 and 8, which I think that I'm going to have this written wrong when I move it. I think it is wrong. Hold on, let me check it. We have, you count the blocks, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I was right. It's 8 over 9, not 9 over 8. However, it needs to be negative because we're decreasing, okay? So you got to put a negative in front of that. Even though I don't have one, you're going to put a negative in front of yours. That's my sad, sad little negative. Okay, so there's the slope formula. You all have that in your notes, so you should have been fine for that. Now, down here, you should notice that problem number 4 was exactly the same as number 1, and problem number 5 was exactly the same as number 2. So if you did them both correctly, then you wouldn't have gotten 5 halves for this one, and you would have gotten negative, whoa, what's going on there? We would have gotten negative 8 ninths for this one. So hopefully all went well there. Look, I can move that little tiny blob that I made. Good. Okay. There we go. So, next, moving on. You had to find the rate of change, which the rate of change, Gordon, what's rate of change same thing as? Excellent. It's same thing as slope. So you had to find the slope. So in order to find the slope, you need 2 points. So within this problem right here, we had 2 points. Here's the first point that you would have had. The first point comes from what you see, 1990, 239, and 2007, 376. So you define the annual rate of change. And Gordon just told us the rate of change is the same thing as slope. So you had to calculate the slope. All right, so when simplified, we get 137 over 10, which also gives us 13.7 over 1. So I think I did that right. I was trying to remember from my other class. So what does the annual rate of change? All right, so what does this mean? This is going to mean that the average amount of spending on dining out increased. $13.7 billion each year. That was the average for each of the years over the 10-year period. Okay? All right, so cable TV, we had to do the same thing. You had to come up with your 2 points. And your 2 points would have been 1992, 52, and 2002, 73. So you're going to find the rate of change. Here we go. Here's the rate of change for the two of those. And again, you were using, let me get my little highlighter here. You were using this as your first point, and you were using this as your second point. And that's what you were doing there, okay? All right, lastly, what does it mean? When this is reduced, you end up with 21 over 10. My division symbols kind of disappeared here. And when you keep reducing, you get 2.1 over 1. All right, so what that means, hopefully you did that, the average number of cable subscribers increased by 2.1 million homes each year.
Yeah.
Woohoo! Is that right, Cole?
Yep.
Yep, very good. All right. Moving on. So that was your homework. I hope you found it on Nedline, and I hope you did well with that, okay? All right, here we go. So remember these? We have a couple yellow papers labeled A, B, and C. 2, A and B has tables, and C has graphs. So what I'd like you to do is take these out right now. Go ahead and look for them. I'm going to move on a little bit while you're finding those. What we're going to be doing today is we're going to be writing linear equations. And we're going to write them given the different tables that we're going to look at. So we're going to be looking at those animal papers and graphs. So you have those different graphs too. All right, here we go. So let's recall that we have a couple formulas that we know right now. All right, and I really highly suggest that you write these down. You should have your slope formula, which we've written down a couple different times. We've written it in our notes. We've written it on your homework. You've written it when you were doing the slope process here and there. So, you know, the bottom one down here, the slope formula, you should hopefully know that by now. Now, this slope-intercept formula in green up here, this, you know, I've just been kind of using from prior knowledge that you guys have done. I haven't really talked about it and used it all that much, but this is what we're going to be focusing on today, which is in this green. Remember, M is the slope and B is the y-intercept. And a lot of times you'll hear teachers say it's the beginning. It's where you begin. So the y-intercept is always where we will begin or start the information. So here we go. We have our sprinting speed for the lion. Oh my goodness, how many times have we seen these problems, right? So we've seen these problems a number of times, and what I want you to do is I want you to add a little column down here. And when you add that little column down there, I want you to look at the pattern. Now notice I am on, oh, it was so straight for like a second. I am using chart B. And chart B is where you're going to get this. So I'm not going to be looking at chart A today, just chart B. So I would like you to figure out what's going to go here. If this is X, what are we going to have here? What's that value going to be?
An O.
You know, Cole? What is it?
O.
What, an O?
1.
1? I guess we're going to have to find out and see, won't we? Okay. So, what do we think is going to go there? Decisions, right? So, Bree, what do you think is going to go there? If you're increasing by 50 each time, this is going to be what? Ding dong. I'm pretty sure she said it. This is going to be 50x, right? Because 50 times any of these is going to work. If you do 50 times 2, you get 100. If you do 50 times 4, you get 200. So 50 is our rate of change. So the average rate of change here, which we have already answered before, is 50 miles per hour. Now, this up here is an expression. This is, sorry, I'm way over here. Give me a second. Get it together, Miss Taz. This is an expression. It is not an equation. An equation has to have an equal sign. So we're going to set this equal to y in order to find the equation. Okay, so we're going to write that equation. So the equation that we're going to have a y equals, I think it's up here somewhere. It's not responding. Oh, there it is. So we're going to have y equals 50x, and that's going to be our equation. Now, really, it's in slope-intercept form. So it should be plus 0, because remember, we have y equals mx plus b. And so this is our m. I'm writing with the mouse. And this is our b. We began at 0. That's what we see here. We began at 0. Now, a lot of times what you see is the problems that we've been looking at. Stop making all that noise, little boy. What we've been looking at is we've been using different variables. So instead of x for time, we could use t. And instead of y for distance, we can use d. So we will start changing these into the form that we've been seeing. So d of t is how we say that. D of t equals 50t. And if you want to write plus 0, you're welcome to write plus 0. You can have it or not. You usually won't see it, but you can have it sometimes. Okay? All right, so let's look at the next one. The bear. So if we continue our pattern down here, my son keeps making noises. I have 2 of them, by the way.
13.
You think the answer's 13? Okay, we'll see.
3 and 0. 3 and 0.
Oh, 3 and 0 is not 13. It's what?
13.
13?
30.
30. There you go.
It's 30.
Okay,
Or
so
60.
Jenna, what are we going to get for our pattern down here? Awesome. Very good. 30x. He knew it, he said. All right, so then we already knew that the average rate of change was 30 miles per hour. So the equation for this then, we know the expression's right here. So our equation then, Anna, would be, very nice, Anna, would be y equals 30x. But remember, we're going to start changing it using t for time and d for distance. And so we would get d of t equals 30t. Everyone should be writing all of this down. These are your notes that you should be taking. Okay? You're not just sitting there watching and listening. So I need you to make sure that you're doing that as well. All right.
I'll do it under there.
All right, so I'm going to ask that the substitute please pause this in a moment. What I would like you all to do is do the next 2. So I think that's the elephant and the reindeer. Take a moment, continue the tables, and write the equations for those 2. Please pause now. All right, so we're back, and I want you to check your answers. Here's the elephant. All right, you should have gotten 25x down here. Here's the rate of change, which we already knew. Here are the equations that you would come up with. Okay, here's the y equation. Here it is in function form, d of t equals 25t.